Hello students, welcome to a new video lesson by Notebook. Before starting with the lesson, let me tell you a little story. Rohit is the star batsman of his school. They are playing their arch rivals at the finals of the Inter-School Cricket Championship. Rohit needs 2 runs to win, but it is the last ball. The fielders close in on him, trying their best not to let the ball cross the 30-yard line. The bowler bowls a tricky one, but Rohit hits it just perfect. The ball sails past the third man and flies over the boundary. It's a 6. As the crowd goes wild with cheers, Rohit mentally thanks his maths teacher. Surprised? By the time you finish with this lesson, you will also realize that Rohit's stellar abilities are not just due to his skill, but also an accurate usage of the theories of lines and angles. You might remember from your previous classes what is a line and angle. Still, here are the definitions once more. A line segment is a portion of a straight line marked by 2 fixed ends. A straight line has no fixed end point and can stretch on endlessly in both directions. A ray is a straight line which has one fixed end point. It can stretch endlessly in one direction only. When 2 rays originate from a single point, they form an angle. Now that we have revised what are lines and angles, let us talk about complementary and supplementary angles. When the sum of 2 angles equal 90 degrees, they are called complementary angles. The 2 complementary angles are called complements of each other. When the sum of 2 angles equals 180 degrees, they are called supplementary angles. The 2 supplementary angles are said to supplement each other. You know that acute angles are angles less than 90 degrees, while obtuse angles are greater than 90 degrees. Here is a helpful chart describing how different combinations of these could be complementary or supplementary. Next, we come to adjacent angles. These angles are like best friends, they always sit together. Have you ever participated in a 3-legged race? Adjacent angles are like just that, joined at an arm. Adjacent angles have a common vertex and a common arm. Therefore, we actually have 3 angles in a given pair of adjacent angles. The 2 adjacent angles along with the larger composite angle formed from the 2. Now, if we take 2 adjacent angles such that their outer arms lie exactly opposite to each other, notice how the outer arms have now become a straight line. Such a pair of adjacent angles are called a linear pair. Notice something interesting. You know that a straight angle measures 180 degrees. And what else measures 180 degrees? Supplementary angles, of course. Supplementary angles always form a linear line, as shown. Now let us move on to something a bit different. I'm sure you have been scolded at least once for playing with scissors, haven't you? Especially for completely opening up the scissors in the shape of an X. Well, in doing so, you have unknowingly created vertically opposite angles. 2 pairs of vertically opposite angles are formed when 2 straight lines intersect. Each pair of vertically opposite angles are equal to each other. How so? Let's find out. Consider a pair of lines AB and CD intersecting at point P. Since AB is a straight line, angles APD and BPD form a linear pair. Let angle APD be X. So angle BPD must be 180 degrees minus X. Now as CD is also a straight line, angle BPD and angle BPC form another linear pair. We know that angle BPD is 180 degrees minus X. So angle BPC must be 180 degrees minus 180 degrees minus X, which is X. So angles BPC and angle APD, which are vertically opposite angles, are equal. Similarly, AB is a straight line. Angle BPC and angle APC forms another linear pair. We know that angle BPC is X. So angle APC must be 180 degrees minus X. This makes angle APC equal to angle BPD. They are also a pair of vertically opposite angles and have been proved to be equal. Hence, we can say that vertically opposite angles are equal. Now that we have discussed vertically opposite angles, here's a little question for you. Is it possible for a pair of lines to intersect in a way that all four vertically opposite angles are exactly equal to each other? Think on this. Now let us take a turn into the last portion of this chapter, transversals and parallel lines. Starting with the first of the two, we face the question, what is a transversal? A transversal is a straight line that intersects a pair of straight lines at two different points. It is a bit like the crossbar of a bicycle or a road intersecting two railway lines at a level crossing. There are some really interesting angles formed by a transversal. Let's check out some of these. First, we have interior angles which lie between the two straight lines as shown in the diagram. Then we have exterior angles which lie on the outside of the two straight lines. Next, we have corresponding angles. After this, we have alternate interior and alternate exterior angles. Finally, we have consecutive interior angles or co-interior angles. Now that we have discussed a transversal, let us discuss what happens when the two lines intersected by a transversal are parallel. Parallel lines, as you might remember from your previous classes, are a pair of straight lines that are separated by a constant fixed distance. They never meet. So, what is so interesting about parallel lines intersected by a transversal? Well, quite a few points actually. Let's discuss them. Firstly, the corresponding angles of two parallel lines are equal. Next, a pair of alternate angles of two parallel lines are also equal. Finally, the co-interior angles of two parallel lines are supplementary. Now, these three theorems also prove the converse. As we know that these properties hold only for a pair of parallel lines, we can say that if such properties hold for any given pair of lines, they must be parallel. So, for a given pair of lines, if corresponding angles are equal, or alternate angles are equal, or co-interior angles are supplementary, they must be parallel. Any one of these three needs to hold in order to prove the parallelism of a pair of lines. With this, we come to the end of today's lesson. We will see you soon with a new video. Until then, goodbye and keep practicing.